Hello everyone. In this video, we are going to discuss about the Docker copy on write strategy, which is also called as the COW strategy. The main purpose of this strategy is to have the efficient storage for the Docker images we prepare. It allows us to share the layers of the image between multiple images and also between multiple containers of the Docker image. Here in the diagram, we can see a Docker image and a Docker container. Here we can see that a Docker image is a combination of multiple layers. So each layer indicates some changes to the local file system. For example, if we write any command in a Docker file, if it tries to change the file system, then it will create a new layer. Here we have two types of layers, the read-only layers and a read-write layer. When we create a Docker image, the image contains all the read-only layers. When we create a container out of this image, we'll have a read-write layer which allows us to change some data in that layer. If we create multiple containers of the same image, then we'll have read-write layer for each of the containers, and the base read-only layers are common for all the containers. These read-only layers are called the image layers, and the read-write layer is called as the container layer. So how Docker maintains the contents of these layers for both the images and containers? To manage the contents of these layers, Docker uses storage drivers. There are multiple storage drivers available like overlay, overlay 2, ZFS, BTRFS, and so on. Here, the read-write layer is a temporary layer. When we create containers, the containers will have this layer to manipulate some temporary data. So when the containers are deleted, this layer will be deleted. So if we create multiple containers, we'll have a read-write layer corresponding to each of the containers. So how this copy on write strategy works? For example, we have a file in one of these layers, maybe in the second layer, and if the container needs to change that file, then it will try to search that file in each of the layers from top to bottom. If it finds the file in the top layer, then it will copy to read-write layer. If it does not find, then it will search in the second layer and in next layer and so on. So wherever it finds, so it copies the file to the top layer for writing or editing. That is why it is called as the copy on write strategy. So this strategy involves the copying of the files to the top layer if it tries to edit the file. So every time the container needs to edit the file, it has to copy corresponding file to the top layer and it will edit there. If the containers do this very often, that will impact the performance of the containers because it involves a lot of I/O. So to improve the performance, the containers need to avoid editing of the files in the image layers. So if it needs some files to be edited very often, the corresponding files need to be shared via Docker volumes or bind mounts. So those Docker volumes or bind mounts will allow to share the files across containers from the disk directly. So here the storage drivers efficiently maintain the layers of the images and containers. These storage drivers allow Docker to share these layers across multiple images and containers. So how it differs from Docker volumes? Docker volumes are used to share the data or files from the disk to the containers. Docker volumes will not share the layers across images. It shares the files or data from the disk to the containers, whereas the storage drivers shares the image layers across multiple images and containers. Now let us see in the demo to understand these image layers and container layers and also the COW strategy. This is a Linux server. Here I have installed Docker. We can verify whether Docker is running or not. The Docker is up and running. Here let us see what is the storage driver this Docker daemon is using. For that we can execute docker info command. From this we can search for storage. So here we can see the storage driver is overlay 2. So we can use different types of these storage drivers based on the operating system. Now let us see about image layers. So to explain this, let us try to download two images, Maven and Tomcat. So let me try to download Tomcat first. So this is getting downloaded from Docker Hub. Here we can see various layers are getting downloaded. So this is the first layer, then second layer, third layer, and so on. So all these layers will be downloaded and these will be stored in the system. These are all image layers which are read-only layers. So now the Tomcat image is downloaded. Let us try to download another image called Maven. So this image also will be downloaded from Docker Hub. So here we can see there are some layers which are already existing in this machine. Here we can see the first 5 layers are already present in the machine and they are common to the Tomcat image. This is because Maven and Tomcat are using JDK as the base image. That means the layers corresponding to JDK will be same for both the images. So multiple layers which are common to different Docker images are shared with each other. This way storage drivers in Docker increases the efficiency of storage. So where these image layers are stored within the host. For that we have a default directory where lib docker, but this can be customized as well. So we can go inside that. Here we can see a directory called overlay2 which stores all the layers corresponding to images and containers. So let us go inside that. Here we can see the hash values of various layers corresponding to the images Tomcat and Maven. If we delete any of the images, then the corresponding layers will be deleted. So let us try to delete the Maven image. So the layers corresponding to Maven are deleted except the layers which are common to Tomcat image. Now we can verify the layers again. So these layers are corresponding to Tomcat image only. Now when we create containers out of this image, new read-write layers will be created for the containers. So let us try to create two containers now. So here I am creating a container T1 based on the Tomcat image. Similarly, let us try to create another container T2. So here we can see two containers are created based on Tomcat image. So we should have some read-write layers corresponding to these two containers. So let us see here. Here we can see some container layers are created for both the containers T1 and T2. So these layers are container layers which are temporary layers. That means if we delete the containers, then these layers will be deleted. So let us try to delete both the containers now. So both the containers are deleted. Let us verify whether the read-write layers are deleted. Now we can see all the layers which are created for T1 and T2 are deleted. Now we have observed that the container layers are temporary and those will be deleted when the containers are deleted. Now let us take an example to explain about the copy on write strategy. For this we will write a Docker file and we will see how the files are copied to one layer from other layer for writing. I have created an example directly. In this we will write a Docker file. So here let us use Ubuntu image as the base image. We are using the latest tag and let us write a maintainer here. I am giving test user. So after this we can write different build instructions within the Docker file as per our requirement. So let us try to save this file as of now and we will try to create a Docker image. The Docker file is saved and let us create a Docker image now. So here it will try to download the Ubuntu image and it will create a base layer corresponding to Ubuntu. So the building of the image is completed. Here we have two instructions. One is from instruction which will create the base layer for us, and this maintainer will not create any layer because it does not change anything in the file system. We can verify that. So here this is the layer corresponding to our Ubuntu image. Now let us try to add a new file in the file system within the same Docker file and we'll rebuild the image. Here we are using run instruction and we are writing a message hello to a test file that will be created inside the temp directory. So basically we are changing something in the file system. So it should create a new layer for us. Let us save this file. The file is saved. Let us rebuild the image. Now this will create a new layer. So here we can see the new instruction is executed as part of the build and it would create a new layer. We can verify the new layer now. This is the new layer created now. So under temp directory, we can verify the file content. So here we can see the new message is added to the file. So here the file is copied to the new layer for editing and the file is edited. So this way the copy on write strategy will work to create different layers for different instructions in Docker. So in this video we have seen the copy on write strategy in Docker. We also discussed about the image layers, the container layers and the storage drivers. And we have gone through all these concepts through demo as well. I hope this video helps. Thanks a lot for watching.